Good afternoon, everybody. So we are having chemistry, and we are going to discuss element, compound, and mixtures. These are the integral and the primitive topics we need to understand in chemistry as far as chemistry is concerned. And we are going to, having understood this, then it will be more easier for us to discuss in details more topics on chemistry. Now, what do we understand by elements? What do we understand by compound? And what do we understand by mixtures? Now, element are substances which cannot be split into simpler form by any simple chemical process. That is, element cannot be split. By now, you all know what the first 20 elements, the basic elements, which are hydrogen, helium, and the rest. Those are what we call what? Elements. They are elements that cannot be separated or splitted into simple chemical process. Now, why do we say they cannot be splitted into simple chemical process? That is, it cannot be divided. We assume for now that it cannot be divided by any simple chemical process. So, which means it is still very possible that they can be divided, but in a complex chemical process, which possibly we'll still discuss there when we get to that aspect. So, element, the example of element is sodium, which is represented by Na, calcium, which is represented by Ca, potassium, which is represented by K, and etc. Now, compounds. Compounds are a combination of two or more elements which are chemically combined together. That is, they are chemically combined together. A very good example is H2SO4 tetrahydrosulfate using the IUPAC nomenclature. It is also called sulfuric acid. HNO3, that is the triiodonitrate 5 acid in the IUPAC nomenclature, which is also called the nitric acid. So compounds. H2SO4, this is a compound. It is chemically combined together. That is, this H2SO4 will have its own characteristics. It is going to have its own properties, which is different from the properties of hydrogen, the properties of sulfur, and the properties of oxygen. That's why we say it is what? Chemically combined together. And we also have mixtures. Mixtures are a combination of two or more substances which are not chemically combined together and can be separated by simple physical process. That is mixture, combination of two or more substances which are not what? Chemically combined together. That is, it can easily be separated by simple physical process. That is, example is salt and water to give us salt solution. When you add salt to water to salt, we are going to have a salt solution which can be reversed. That is why we call it what? A mixture. Petrol and ethanol. Petrol and ethanol is what? It's a mixture. So it can be what? Reversed. Now we can now look at the comparative aspect of compound and mixture. That is, what are the differences between compound and mixture? Now we say we have compound and we have mixture. Now, the first one, compounds, they are chemically combined together, while mixtures not chemically combined together. I've explained this. I said compounds are chemically combined together, while mixtures are not chemically combined together. That is, compound, which is the reaction, which is a chemical reaction, while mixture is not a chemical reaction. That is, when we talk about mixture, it can be easily reversible. That is, it is just a physical. Now, in compound, heat is involved. Heat is not necessarily involved. That is, in a compound, heat is necessarily involved. That is, even when we are to have deduce a compound by ourselves, like for instance H-hydrochloric acid, whereby we have a direct combination of constituent elements like hydrogen and chlorine, it is necessarily involved to have that chemical combination of HCl. So, but in the mixture, it is not necessarily involved. For instance, that salt and water, the mixture of that salt and water, we don't really need it. But in compound, it is really involved for us to have compound. For instance, when you have a reaction of acid and base to give us salt and water, it is either evolved or it is absorbed. That's when we'll be talking about the endothermic and exothermic reaction. So it is involved in compound and it is not necessarily involved in mixture. We also have, for compound, they are homogeneous, while mixtures, they are either homogeneous or heterogeneous. For compound are always homogeneous. What do you mean by homogeneity? Homogeneous is it has just one phase. For instance, when you take your paracetamol is deduced by pharmacists using a formula. That's when you break your paracetamol, it will have that all white. That does not mean that all the constituents that is used in making paracetamol is all white. But since it is a reaction, then it's going to have what? All white, which is a compound. That's what we call by homogeneity, having just one single phase or color. Then we have mixture. They are either homogeneous or heterogeneous. That is, for instance, homogeneity we can have mixtures which is homogeneous or heterogeneous. For instance, salt solution. Salt plus water. You are going to have a clear phase of what? Salt and water. When you have a salt solution in a cup and we have a sugar solution also in a cup, which both of them they are mixtures, you cannot easily identify if you're not there that this is what? This is salt solution or this is sugar solution. That is homogeneity. That is, but heterogeneous. For heterogeneous, it means it can have different phases. For instance, when you mix sand and salt or sand and palm oil together, then it means you see that there is sand in this substance and there is also palm oil in this substance. That's what heterogeneous. So in compounds they are always homogeneous, while in mixtures they are either homogeneous or heterogeneous. They can for compounds they can be represented by a chemical formula. And mixtures, they cannot be represented by a chemical formula. Now, for compound, they can be represented by a formula that I gave the example of sulfuric acid, which is H2SO4, the nitric acid, which is HNO3, or sodium chloride, which is NaCl. We can always represent compound with a chemical formula, but mixtures cannot be represented by a chemical formula because it is just a physical mixture, not a chemical mixture. So it can never be represented by a chemical formula. And again, compounds they are added by a fixed ratio. And for mixtures they are added by any ratio or amount. Now, what do we mean by they are added for compound? What do we mean by they are added by a fixed ratio? A fixed ratio, you will see, you can always hear anywhere in the world when you are told what is the formula for water, you will hear it is H2O. That is, we have two atoms of hydrogen combined with one atom of oxygen to give us water. That is a standard formula. That is, it is combination of two atoms of hydrogen plus one atom of oxygen to give us water. But in the mixture you can add salt and water. You don't need, for you to get a salt solution, you don't need anybody to tell you that take a ratio of water and take a ratio of salt. It can be added in any ratio depending on how you need it. So far or you want to make a milk solution, you don't really need any ratio. You add any quantity that you feel it is needed. So these are the differences between compound and mixture. So having known what compound and mixture is, then we say mixtures can be separated. They are easily separated by simple physical means. So this will lead us to our next topic, which will be method of separating mixtures, and we call it separation techniques in chemistry. So in our next class we are going to treat that. So what we call separation techniques and the method use a separating texting. So thank you very much.